Now take a look at example 2, the same type of problem. This one already has the denominator factored. One extra thing happening here, x minus 1 is being to the second power. Okay, so there's a little different breakdown here for partial fraction decomposition for this one. So I have x squared plus 2x plus 7 all over x times x minus 1 squared. Okay. When you have a linear binomial to a power, and it has to be linear, x to the first power plus or minus 1. If you start getting into seconds and thirds and whatever powers, then there might be some other weird stuff going on. We'll deal with that tomorrow. But linear binomial to a power, this is how you, or even if it was just x squared, I mean, you know, it can't be broken down any further than that. I'm going to get a over x, the expected thing you get for the x object. Anytime you have a binomial to a power, you're going to have to account for every power of that binomial over here. So I'm going to have b over x minus 1 to the first, and c over x minus 1 to the second. If it was to the third, it'd be plus d over x minus 1 to the third. So every power of x minus 1 has to be accounted for as a possible piece to the sum. If I happen to get b equals 0 or c equals 0, something like that, then of course we throw that term out. But we have to account for the possibility that it exists as part of the problem. So once I've done that, now it's just a matter of multiplying everything times the least common denominator, which again is always just whatever this one is over here. So x times x minus 1 squared. So the first object just becomes the numerator, x squared plus 2x plus 7. A over x, x cancels x, so I'm going to get a times x minus 1 squared. I can go ahead and square that binomial, x squared minus 2x plus 1. You're going to save yourself a little bit of time. When b over x minus 1 multiplies by this, one of the x minus 1's cancel, the other one doesn't. So I've got a total of bx times x minus 1. And when c over x minus 1 squared multiplies, the x minus 1 squareds multiply, or cancel out, leaving me as plus cx. And if you take a look, we have squared first power constant, we have squared first power constant. This is going to be squared first power, and there's first power. So we're going to have pieces that are going to create all these structures, right? Even if I didn't have squared over here, let's just say that x squared wasn't even there, and I got some squareds over here, that just means that a plus b would equal 0. So I mean, you can still create a structure for the correct answer. So I'll just use some different colors again. I'm going to go 1x squared plus 2x plus 7. Let's go that route. So when I multiply through, I'm going to get a times x squared. I'm going to get minus 2ax. I'm going to get plus a. And then I'm going to get plus bx squared minus bx, and then plus cx. And with colors, it's pretty obvious, right? A is equal to 7. That happens sometimes too. This is would be a system of 3 equations. There's 3 unknowns, but I can right off the bat see that a has to equal 7. So now any fact about a, if I just want to write 7, I can do that. So if I try and create a system of equations, here's my little brace there to create a system of equations. I know that a plus b has to equal 1, right? But we know a is equal to 7, so that means 7 plus b is equal to 1. That leads me directly to b must equal negative 6. I can also see that negative 2a minus b plus c has to equal positive 2. Well, minus 2a is just minus 2 times 7, that's minus 14. Minus b is going to be minus 6, which is plus 6. Plus c has to equal 2. And that leads me to negative 8 plus c is equal to 2. Which means that c must equal 10. Okay, so sometimes you can kind of go one at a time and find the answer. Sometimes you can't. So like the last problem where we couldn't find a or b individually, sometimes it's just right there, staring right in the face. A is equal to this number, and then you can kind of step your way through the whole thing. Once I know what A, B, and C all equal, then it's just a matter of writing the answer. So again, the answer is right here, replacing A, B, and C with their numerical values. So A is equal to 7, which goes over X. B is equal to negative 6. Actually, I put a minus sign here probably. For negatives, I just put a minus instead of a plus. And then 6 over X minus 1 to the first. And then C is positive 10, so plus 10 over X minus 1 squared. That fraction sum would add up to this fraction.